Thanks for coming and taking the time to listen to this talk and hopefully to ask some questions. Very quick introduction. My name is James Duez. I would describe myself as a recovering software engineer. You're never truly healed. I've spent the last 15 plus years in AI and automation. Before that, I had a 15-year career in business risk, ethics, and compliance. I'm also CEO and co-founder of Rainbird.ai. We exist because the world actually needs AI it can trust. And for the last 10 years, we have automated complex decision making for some of the largest companies in the world using advanced symbolic AI, a term you maybe haven't heard, but something I will later go on to define. There's a lot we can do today with AI, but there's also a lot of hype and a lot of misunderstanding. I'm hopefully going to provide you with a good deal of context, a hitchhiker's guide to AI today, because you know what, it's bound to change again tomorrow. Of course, The Hitchhiker's Guide to the Galaxy refers to the award-winning books by Douglas Adams. Now, all of my images, by the way, in this presentation were created using Midjourney, one of the leading generative AI platforms. This is what Midjourney version 5 thinks Douglas Adams looks like, sitting in front of the great computer Deep Thought featured in those books. Now, The Hitchhiker's Guide was published as a radio play some 45 years ago. Many of you will know the books or the 2005 film. It actually remains as funny now as it was then. That's my personal opinion. But what was The Hitchhiker's Guide in this fantastic comedy? Well, The Hitchhiker's Guide was a book that served as, and I quote, the standard repository for all knowledge and wisdom. Now, that sounds a little bit like the promise of ChatGPT, although I am going to highlight that ChatGPT, which of course has got everybody's attention in recent months, whilst exceptionally clever and useful, I would say doesn't contain knowledge or wisdom. So let's just take a little look at what we're going to cover in this webinar. We have to talk about the hype because we are in a hype cycle. I wanted to make sure that we demystify some terms and some technologies. Let's just go back to basic and make sure that we all have the same understanding. We need to cover a human's view of exponential change, something that us human beings aren't particularly good at. I want to cover why trust matters. And we're going to talk about these very two worlds, how planet data has been quite separate from planet process, but decision intelligence is becoming the gravity that's building these two different perspectives together. We've got to talk about the near-term opportunities, but of course that comes with risks. I'm going to talk through and show you a small example, and I'm sure we're going to get into some questions and answers. If you have any questions, please feel free to put them in the chat, and we'll be able to cover those towards the end. Now, there have been many hype cycles around AI as it's gone in and out of fashion over many decades, really since the 1950s, and we call these the sort of summers and winters. And to avoid any doubt, we are absolutely in a hype cycle now. This is a very different sort of hype graph. This is NVIDIA's share price since January. For those of you that are not familiar, NVIDIA make chips that are used to build these very large language models and these big AI models. Now, a key advisor to the UK Prime Minister, Rishi Sunak, has denied saying that the world has only 2 years to save humanity from the threat of AI. But despite this denial, this fictitious comment was still echoed in much of the UK media, even though it doesn't reflect what he said. Now, you can see how much excitement, but also hysteria, anxiety, and perhaps a little bit of panic there's been around this topic. Part of the problem is that with this whole space really is that people misunderstand what artificial intelligence is. And specifically, I think it's the word intelligence that trips people up. AI is embedded in our culture from stories and movies like Ex Machina. This is, again, a screenshot generated by Midjourney of what an Ex Machina film may have contained. Part of the challenge with this term AI actually is its definition. It's pretty self-defeating. Now, the term artificial intelligence was coined by John McCarthy back in 1955. And there are many definitions, but we might roughly accept that a computer performing a task that we thought was intrinsically human, something that required a human, is our definition of AI. And of course, the problem is when something works, it no longer meets this definition. And this is what's known as the AI effect. And it's the reason why actually we don't recognize a whole lot of AI that we live with today. You don't think of your satellite navigation system as AI, but before sat-navs were common, they were considered AI. The same with chess computers. When Garry Kasparov was beaten by IBM's Deep Blue in 1997, just before that moment, there were many people who thought, well, if ever it was possible for a computer to beat a human as chess, that would almost be the end. Seems a bit ridiculous now when we say that. So AI sometimes can be sort of described as, everything that maybe doesn't quite work yet or hasn't quite added value. It just reveals itself to be what it always was when it works, the next generation of computer science. And the other point to recognize is that all of the AI that we have in use today is actually pretty narrow in its application. It's why we call it artificial narrow intelligence. Narrow solutions can be applied to very specific problems where we can test them and we can make sure they do what we want. Artificial general intelligence, which is of course a term we're all beginning to get more familiar with, I would argue is still some way off. We won't get into that big debate, but despite the fact that for some ChatGPT looks a bit like AGI, it has some limitations, and I think we have a way to go. So let's just talk about some terms and make sure we understand them. I think the first thing is that artificial intelligence itself isn't a very helpful term because it describes a very broad number of technologies. And the term machine learning, like the term AI, is also a broad category and therefore can be somewhat unhelpful. But let's maybe agree and conclude that machine learning is any system that's using data to create algorithms without explicitly writing them. Now, symbolic AI is the opposite. It actually has to be explicitly programmed, and it works much the same way as we teach people. And symbolic AI was all the rage before machine learning. The last time AI was interesting, back in the late 1990s. And the current focus, which I've chosen to break out separately because of the hype around large language models like GPT-4, which powers OpenAI's ChatGPT, these are models that generate content, hence the name generative AI, but should really be in the machine learning category. They are part of that machine learning world. And as I go through this webinar about machine learning, please remember that large language models, like the ones powering ChatGPT, are also based on machine learning. Now, why is that important? This is the big challenge with machine learning. Take a look at my favorite cartoon. I'm just going to be quiet for a second to give you a moment to absorb. This is an old cartoon, but it is still very relevant. The task of a machine learning model is ultimately to make a prediction. And in the case of generative AI, to predict what might logically follow what you've given it. Large language models are based on machine learning. They are, of course, maths, not magic, even though they can look pretty magical. Now, if I was to ask a machine learning model why it's made a specific prediction, right? If it could actually answer me, it might say, you wouldn't understand. You don't speak my language. It is a statistical, mathematical prediction. They're making predictions as to what should come next. Now, those predictions, of course, can be completely right, but they can look right and be wrong, or look wrong and be right. And because they're not readily interpretable, we talk a lot about explainability in AI. Yes, we can sort of explain how these models are engineered, but I'm talking about explainability at a transaction level. Why did you make that prediction, right? Because they're hard to interpret. It's hard to know the difference whether between this right and wrong, unless you are the expert. So look, machine learning is amazing and incredibly powerful, and it's changed the world. But we just need to recognize these as predictions, which maybe we could argue are not the same as judgment. Now, I sometimes get challenged. It's a perfectly good challenge on the semantics here. Is there really a difference between prediction and judgment? We make predictions. Well, I would argue that predictions are typically data-driven, sometimes machine-learned forecasts of future outcomes based on historical data and neural networks. They are the neuro part of an incomplete equation. Judgments are the evaluation of predictions, which are actually are based on our beliefs as humans. Beliefs, values, experiences, sometimes regulations, standards, and rules. These are, when we express them in software, are symbolic. We might call the symbolic the other half of this equation. So we have this kind of neuro-predictive thing going on, and we have this symbolic judgment piece. And neuro-symbolic, again, is a term I'm going to be coming to talk about. But I would argue that a genuinely high-value autonomous decision should probably be informed by the past and measured, moderated, or judged by the standards that we set as humans. Both data and knowledge must be reasoned over to form a decision. And that process should really be subject to scrutiny and inspection to ensure that we can understand the chain of reasoning, something we're used to explaining as human beings. Now, Tim Urban talks about how this all looks utterly exponential. Us humans are very bad at understanding exponential rates of change because we look behind us and it looks like we've kind of had this somewhat slow climb. And then yet when we look ahead of us, it looks like a brick wall practically of innovation. Actually, if we were to zoom in, what we would see is a series of S-curves. Each of these are little hype cycles. We have a hype cycle at the moment, of course, and at the top of each of these mini S-curves, we then sort of see that hype, and then the innovation matures, we lose the hype, and we start to increase our trust. Now, trust in these cycles is really important because ultimately it's trust that breeds adoption. If you don't have trust, you won't have much adoption. So the question I want to ask is, do we trust this technology that we have today, especially the technology that's not always easy to understand and interpret? Well, some trust it, some don't. But a quick history lesson on this. I present to you the humble microwave. I like this picture of a microwave. It's kind of 1960s funky microwave. This became popular in the late 70s and 80s. We're all very familiar with them. We probably have them in our houses. But they were invented in 1945, right? They took decades to get to the point where they were adopted. And a large part of that was about trust. People had to trust them. Governments had to trust them. Some of this delay was because of new regulation that needed to be created, such as the new regulation that's being created now to adapt to this new world of AI. My grandmother would not have a microwave in the house, by the way, because she was just terrified of it. My mother would have a microwave, but my brothers and I were not allowed to stand too close to it when it was cooking. But anyway, are you seeing the parallel? Adoption requires us to have trust and to some extent a degree of regulation. So look, I've been banging on about machine learning, which I would describe as being an analysis technology. That's what all machine learning is doing, including ChatGPT and other large language models. But what about process and automation? Now, while many people are focused on data and insights, others have been very focused on the automation of human tasks. It's almost like we've had two entirely different worlds. Let's start with the residents of Planet Data. I would argue that the residents of Planet Data have a bit of a data obsession, a data fetish. I would put myself in this category. They're utterly focused. We're utterly focused on the science of machine learning, building predictive algorithms from historical data. And we're motivated by insights, not automation. Now, if you think about it, every time someone tries to delegate responsibility to machine learning for doing something critical, right? We're not talking about predicting what movie to offer you next. We're talking about making critical decisions, right? Underwriting a loan. Can you have a mortgage? How should we price this insurance policy? It requires some sort of human oversight. You know, even if you're driving a Tesla with the AI mode enabled, you still need to be ready to grab the wheel. And this is also very clear with generative AI tools like ChatGPT, powered by GPT-4, right? Yeah, it's been a veritable nuclear bomb that has gone off in the middle of the business world, the healthcare world, the finance world, creating a lot of hype because it is so impressive. It's once again put AI front and center of the public consciousness, and everyone's trying to figure out how to adopt more AI safely and responsibly. But adopters of LLMs, large language models, quickly see the challenges. They're slowly realizing that actually, you know what? These are co-pilots to experts. We need to be the expert to get value from generative AI because it can be prone to hallucinations, right? Now, hallucinations can be highly functional, but hallucinations can also be a mistake. You need to be able to ready to grab the wheel or at least perhaps apply some judgment. So like all large language machine learning, large language models are useful for making these predictions. But you've got to be the subject matter expert capable of smelling the bullshit. And forgive me, I do mean that in the technical sense. Bullshit is described or defined as convincing sounding nonsense devoid of truth. And sometimes, just sometimes, machine learning can be quite good at creating it. So look, I've totally labeled the point about machine learning. It's a powerful predictor and it's part of our ecosystem, but it cannot replicate human reasoning or complex decision making, particularly in regulated markets. We can't delegate responsibility to large language models or other forms of machine learning to make a decision alone because they lack that transparency. And without transparency, we have no trust. And without trust, we have little adoption, right? By the way, I spoke to a leading industry analyst 2 weeks ago who told me that 40% of all inbound inquiries from enterprise is now asking the question, how can we govern large language models? So let's talk about the process people, okay? Because I'm on this world as well. Population of planet process is focused on efficiency. We've been making our living leveraging workflow tools, business process management, robotic process automation, RPA, and now intelligent automation. But the imperative here is to take away the repetitive heavy lifting of office tasks by automating them. Planet process people are generally not machine learning people, right? Entirely focused on reducing human effort and error, mainly actually to liberate people for higher value tasks, sometimes to reduce costs. Now, many of the problems that can be fixed by workflow and robotic process automation have already been automated. It's why some are narrating that the age of RPA is dead. But this has opened up new frontiers. One of those frontiers is process mining. So the science of using discovery tools to find the next process to go and automate. But of course, the other frontier is AI, moving beyond the automation of simple tasks towards more complex ones powered by AI. And historically, the toolkits used by those that live on planet process have so far been mostly linear in nature. They're designed around the principle that an automated process will do one thing and then another, branching at various stages, kind of if this, then that. And eventually, should something more sophisticated be required, let's just defer that to a human. And if you look at any process diagram, sitting at the fringes will be humans lurking, waiting to take on decision-intensive, human-only work. And until now, if you wanted to do something complex on planet process, there's really been no choice but to defer to humans because linear rules can't replicate human reasoning. And machine learning has had this challenge of explainability. But machine learning is what we've got, we've been trying to leverage. An interesting side point, all the data used to train machine learning, of course, I would say always stems from some kind of process. It comes from planet process and the decisions that result of mostly humans doing human work. Machine learning is in essence extracting insights from other processes, many of which were human and humans performing particular tasks to particular rules to start with. So look, let's just look at these two worlds in detail, because actually what we want to do is bridge this chasm. So we have so we have people on planet data. Huge leaps are being made with large language models. Expectations are exceptionally high, but we recognize these as predictions, perhaps not judgments. Data availability, of course, remains a challenge. You can't build a machine learning model if you don't have data. That's not ever been possible. And we know that we struggle not just with data availability, but with bias and these challenges around explainability. But these predictions, they're very powerful, but there's kind of a gap between that data prediction and the ability maybe sometimes to take action. And then we have everybody else living on planet process. Linear rules engines are too simple to automate complex processes, okay? We cannot create a decision tree that can reason like a human can reason. Robotic process automation is only good for simple tasks. Process mining, there's something in that, but that's also quite expensive and complexity grows. Workflows still require ultimately for humans to go and do human work. And there is a kind of a gravitational force that's bringing these two worlds together because, as I said, everybody on planet data is trying to think about how we can action this. And the action is around decision science. It's around people making decisions. How can we leverage data to increase the quality and the efficiency of decision making? And if you've been working on process automation, processing all the simple tasks, you eventually come to processes that still require large numbers of people, the complex contextual decisions that require humans with lots of training and experience. So we can now start to automate complex and situational human-centric decision-making using this category called decision intelligence. We can deal and actually build models even when we don't have data. We can start building models from knowledge, much the same way as we would train human beings. We can train models by leveraging machine learning, large language models. We can train models even if we don't have data, starting with knowledge. And we can build models now that are transparent, auditable, and actionable, where every outcome, every individual decision that is being made by an AI model comes not with a prediction of an explanation as to why that's the right answer, which is what something like ChatGPT will do, but an actual chain of reasoning. And actually, this I would call neuro-symbolic AI. And I was alluding to this earlier on, and this is the domain where Rainbird plays. Now, This is a whole other subject that I'm not going to go into now because we don't have time, but it is going to be the subject of another webinar that we're going to run in a few weeks, because it actually warrants more time on its own. It describes the future of where AI is going. It's actually, I would say, it's the solution to squaring what for 20 years has been a seemingly intractable circle. It bridges this gap that there is from structured symbolic process models and fuzzy real world machine learning models to deliver something that is truly transparent, data-driven reasoning, right? Because machine learning can enable us to get away from this, what we call the closed world assumption, that if we build a decision tree or a knowledge graph model, it only knows what it's been told. But actually, we can leverage that to bring explainability to what machine learning is doing and solve its explainability problem. These technologies come together to solve each other's problems, and it is an absolute superpower for anyone who's adopting it. So look, coming back to this slide, let's just make sure we've understood these definitions. We've discussed machine learning that makes predictions, avoids this need for explicit encoding, but at the expense of a pretty unquenchable thirst for clean data, these challenges around transparency and the risk of bias. Symbolic AI is a lot of what Planet Process is about. We train it like we train people, gives us transparency, but actually at the expense of needing to explicitly encode the domain we want to automate. And this has been Rainbird's 10-year history. And we've talked a little bit about the current hype of LLMs like ChatGPT, good actually at predicting answers, but you need to be the expert to interpret them, but actually exceptional at understanding language. So let's maybe just take a quick dive into the opportunities, the near-term opportunities. I'll give you a moment to read this cartoon. It's actually like 10 years ago when everybody wanted to build an app. We need an app, we need an app. What should the app do? I don't know, but we just need one. We had the same kind of hype that there was around chatbots, and it feels a little bit the same. It's like there's kind of an unlimited budget for AI now again, and perhaps an overwhelming excitement, even if there's a bit of anxiety and panic about how to deploy it. But look, just focusing on generative AI, it's very good at understanding language, astonishing, in fact. In fact, I would argue that it has displaced a huge amount of previous research into natural language processing and natural language understanding. A lot of us have been very focused on generative AI for extracting knowledge. I want to ask it a question and see whether it can answer that question. But actually, its ability to parse and interpret and transform language is really exceptional. Good examples are interfaces with customers and other humans. It's effective at helping us structure unstructured text, extracting concepts from notes, for example. LLMs are very good at sentiment, and they're very good, obviously, the whole generative AI phenomenon. They're very good at generating content. But of course, that has to be carefully controlled. And this is where most people are focused. We just have to remember that this is predictive, not judgment. And we don't delegate responsibility to these things that are unchecked. What are the near-term risks? Well, prediction is not the same as judgment. That seems obvious, and I've kind of labored this point. People, as I mentioned before, people talk about ChatGPT and large language models hallucinating. That's functional if you want to create write a creative story, a novel, for example, or a poem, or some of these things that we've all played with. But one person's creativity is another person's mistake. So we just need to be cognizant of that. Evidence from a large language model is not evidence. It's a prediction of evidence. I actually was chatting to a venture capitalist in Silicon Valley a few weeks ago and had made actual 7 investments in the LLM space and actually hadn't clocked that when you ask ChatGPT to explain why it's come up with an answer, what it's doing, as it did with the answer, is just predicting the next string that logically follows what you've said. That's not quite the same as a chain of reasoning. ChatGPT is not GPT, right? ChatGPT is been incredibly, it's responsible for this huge democratization of this capability. It's very cheap, it's very useful, but everything that's cheap, you're the product, right? So its ability to internalize what you're giving it has some challenges with its terms and conditions. The data privacy risks around LLMs, that this does need to be carefully understood. There's already high profile data breaches around ChatGPT, including Samsung, doctors, lawyers. They're all pretty well written about. But I think, prompts sent to most cloud-based solutions are not keeping that data. Amazon, Google, and Microsoft, you can generally opt out of that kind of monitoring capability. I think it's important, a point of caution, that individual AI-based productivity tools that create content or check grammar, and some of these have far fewer controls, and around data privacy, they actually present more risk. But the engine behind ChatGPT, GPT-4, can of course directly be used via API. It doesn't suffer from your data becoming part of the model, and you can now run GPT-4 in Azure on your own infrastructure, for example. Ownership. These models are not yours. The cost is coming down, but I think it was fairly well recognized that GPT-4 cost $100 million or more in processing time to train. There are the cost of building these simpler models now is coming down, but you don't even necessarily need to build your own models. Other models exist, and billions is going into the open source community. So I wouldn't dismiss that either. Just a quick note on copyright. One of the reasons why I use Midjourney to create these images is just to make the point that even though I created them in Midjourney, certainly thanks to a US case that was passed not long ago, these images are not mine. It's been deemed that there's not enough creativity in me writing prompts to create these generative AI images for me to own those images. And incidentally, it's been now been passed in the court that you can't copyright prompts either. Nobody owns the copyright of these. Now, the risk here is that actually, is this legislation going to stop at images, right? So legal precedent is certainly evolving, and it may be that other forms of generative output, the copyright of those is somewhat in copyright limbo. I'm going to make one small comment on prompt engineering. This idea, for those who are not aware, you use prompts for clearly for creating these generative outputs. I would actually argue that the prompt engineering, there really is no such thing. Engineering is a discipline that has rigor. Prompt engineering is still quite hand wavy. It lacks rigor. It's not like we're building a bridge or a full piece of software. So people just need to not fall into the trap, particularly when people are publishing lots of prompts, to think that that's a rigorous discipline. At this point, it's still evolving. So this is what a symbolic AI model looks like. This is a regulatory compliance model that was built actually by hand by experts in this domain. This particular one is able to make know your client KYC onboarding decisions for a bank. It does due diligence and enhanced due diligence. It goes off to different systems, and it's able to meet all of the regulatory requirements for onboarding a customer in a financial service setting. Yeah, it's non-linear. It's not a decision tree. You're able to, it's a holistic representation of knowledge, and it can emulate the complex contextual human decision-making. And you could do this in any domain. But we're now able to harness the power of large language models and use them in conjunction with symbolic models like Rainbird. I've explained that LLMs are very good at understanding language. We can't delegate responsibility to a large language model today to do this sort of financial onboarding because regulators won't let us, apart from anything else. But we can leverage large language models to help us build symbolic models that can be used. Let me show you a very quick video. This video is showing us creating a Rainbird model, in this case, using a large language model. And in this case, we're using GPT-4, which has already been integrated into our model building application. Here, we're copying some formal regulations that a lender has to adhere to. Forgive me, this is a financial service example around credit decisioning, but this could be any formal knowledge. Now, when we think about building machine learning models, we typically start with data, but here we can start with knowledge. We're just pasting in this content into, in this case, Rainbird co-author, but this is GPT-4 behind the scenes. And, Rainbird is a symbolic AI, which is very visible and explainable. So we're actually leveraging a sort of uninterpretable black box model that we can't really understand to create a glass box model that we can. And here you can see, customers have assets, income, savings, credit limits. These are things that a firm will consider when lending money. And because we've just taken some structured documentation that describes the rules we have to adhere to, we've actually been able to create those rules in this model. So unlike GPT-4, this model, when we query it, can provide a full chain of reasoning because it can navigate what we call a knowledge map, this knowledge graph, and come up with an outcome and a decision. It's entirely explainable. Now, there are an infinite number of use cases for this sort of AI. This is my sort of penultimate slide. So let me just give you another example. This is actually a real use case. Rainbird is being used to authorize medical treatment in the US. It's an area where, you can imagine the expertise necessary to model a medical authorization process. I mean, initially that comes from documents, it comes from regulations, it comes from state policy, it comes from experts. We don't need to start with data. We can start with the rules we've written down for people to follow when we've trained them to make these sorts of decisions. We can use a large language model to help us build a transparent model like the one that you've just seen. It's subject to inspection. You can identify any bias that may have come out of the data or the documentation. It's visual. But of course, you may have historic data, which you can then use traditional machine learning alongside this symbolic model to refine the model to make it better. And the model by this point is getting smart, right? And we've been able to build it even before we've had a whole load of data. And that model is explainable. It's explainable to regulators. It can explain the entire chain of reasoning for every decision. It makes you can make some have it make some test scenarios, ones that go beyond that data. You can get your most seasoned experts, the ones who've been there for 30 years and have seen it all, the ones that everybody defers to, the philosophy of decision making, and have them give feedback on complex real world scenarios to make the model stronger. This is like no other sort of AI, right? It can go beyond the closed world assumption of this whole symbolic AI phenomenon. It can leverage our data. It can explain not only how the model works, this kind of macro explainability, but how each and every decision was made. Maybe we'll call that local or micro explainability. It can breed trust because of that, and trust can breed adoption. And we can do this while keeping a human in the loop. This is not a system that's going to evolve itself. It can suggest changes and present those to an expert and say, do we want to take these new things into account? A trusted, transparent model that you own. Now, this is not the future of AI. This is actually what's here today. And it's very much the focus of my particular interest in what we're doing. Look, I'm going to stop there. Thanks again for coming and hearing me speak. You've been very patient. I'm very happy to take questions on this or any other area of AI. Hopefully we'll have Sabu back. I'm going to hand back to Sabu, who hopefully his microphone is working and he'll be able to give us any questions that we've got.
Thank you for that, James. And yes, my microphone is working, user error, so sorry about that. Thank you for that insightful presentation. Your passion for AI clearly shines through. Now we'd like to open the floor for questions. A fantastic opportunity to tap into James's wealth of knowledge, so please don't hesitate to ask your questions. While we wait for, could I just ask you a few questions, James, before? So how does Rainbird handle things like data privacy? What measures are in place to protect user data?
Look, I mean, Rainbird's an enterprise platform, right? So security is baked in as standard. We're compliant with ISO 27001. All our data is encrypted. We adhere to, all of the software development practices that you would expect. But I think the question is probably more around LLMs. In terms of leveraging large language models, currently within Rainbird, we're using GPT-4, but not ChatGPT. So nothing's going to internalize your data, which is used for the building of models, right? So it's not ingesting your data. Once you've got the Rainbird model, you're running personal data, perhaps depending on your use case, through that. You're not having to run it through the LLM. So actually, this is where when I was starting to talk about neuro-symbolic AI and what actually Gartner started to call a composite AI, where we're using these different methods, we can use large language models as part of building these. But even when we use it as part of a transaction, and this is something we're developing, we're very close to having LLMs that sit on our infrastructure as a completely integrated part of our application with all of the security controls that are there. So certainly from an enterprise point of view, we're very clear. Our data belongs to our clients, and we make sure that when we're using an LLM, that's not going to cause any privacy issues for our customers.
Thank you for that. And just as a follow-up question, who owns those models that you create? Because that's one of the other things I've heard about AI models. Who owns it? Who takes responsibility for those decisions that it makes?
Yeah, I mean, Rainbird models are owned by their clients that build them. Rainbird is an ecosystem for building AI models. The people that build them own them. It's a vehicle for taking all of your intellectual IP as we move into a world where we're trying to build digital services rather than just keep adding people to our headcount, and turn this IP into decision services that are yours, right? They're encrypted, they're private, they're your IP. In fact, within Rainbird, anybody who builds a model in Rainbird, our enterprise environment, Rainbird doesn't even know what those models are. They're entirely yours. You deploy them. So yeah, pretty straightforward. Clients own their own AI. We provide the ecosystem for them to be able to build these types of intelligent solutions.
So I'm just looking at questions over here. So question, this is from Thomas. I think you can see it on the screen. Can you give an example of explainability in healthcare? A unique use case you could provide us with?
Oh, yes, good question. Thank you, Thomas. There's lots of examples of use cases we've been doing in healthcare. We've built, to give you the first project we ever did in healthcare was actually as the pandemic was breaking. We built a risk assessment for the National Health Service in the UK that was able to identify how likely any frontline worker, the 1.4 million frontline workers in the NHS England, were to be damaged by COVID as what we knew of the disease was evolving, right? So you imagine you've got to protect and identify who do you need to shield, who can work in a COVID ward, who needs to have plastic or perspex behind them, based on your entire medical history, based on your ethnicity, your biological sex, how old you are, all of which were factors around COVID. It's not enough to just say, yes, you're high risk, yes, you're low risk. You need to be able to explain the rationale why. And so the ability to create that chain of reasoning that builds confidence in the system. But, in the US, for example, we're doing on a provider enrollment, we're doing claims, we're doing prior authorization, which is the example I was talking about. These are decisions where what really matters is that we meet all the regulatory requirements, we understand the basis of why these machines are telling us what they're telling us, and humans stay in control. It's about the complementarity of humans and machines, transparency and trust. So yeah, every use case that we've built over the last 10 years, most of them have tended to revolve around decisions where, yes, of course, we a good use case for Rainbird is one where there are recurring decisions day in, day out, where you've got people making these very important decisions, but you care about the quality of the decision. It's the value isn't just in doing a process faster, right? That's the domain of RPA. The value is in better quality judgments, right? If I'm going to authorize a medical treatment, there's value in that decision being right. If I'm going to deny you, there's value in that decision being right. And we care about the why. We care about the why because it gives us the evidence and the truth, the evidence that we need to be confident and therefore to be able to adopt more of this category.
Thanks, James. A question from Mia Lancaster. So for someone wanting to exploit process mining, where would you advise them to start? What are the first steps?
Oh, that's a good question. I mean, there are some very powerful process mining platforms that are out there. If you want us to share our view on them, drop us an email, engage@rainbird.ai, and we would love to share you our view. We work very closely with pretty much every process mining and robotic process automation platform that are out there. So we're integrated into UiPath, Blue Prism, Pega, lots of others that are out there. And these businesses, some of these have process mining capability. So yeah, I mean, that's probably one that we pop us an email. We'll come back with some specific recommendations. But certainly, I would think about the whole ecosystem that you buy into needs to be integrated. So when you're thinking about deciding what process mining solution you want to make sure that you've got something that's integrated into your whole automation stack. That's a whole other world.
Thanks for that. And this is a mention from Chris on Chris McKibben. So he's talking about the positioning, the whole thing as an ecosystem. Could you develop a little bit more into what that means? Why is it in? Because why can't we just do one tool for everything?
Yeah, look, I think it's actually, thanks, Chris. It's a really great question and provocation because the world is used to buying point solutions. We buy a solution that does this one piece. We buy a solution that does this piece. And actually, AI is not one thing. Machine learning is not one thing. It is an ecosystem of different technologies that have different strengths and can complement each other. And so we're moving to a world where organizations are buying fewer point solutions and they're investing in platforms, right? RPA is a platform. Decision intelligence like Rainbird is a platform. These are ecosystems that are not trying to displace other software. They are ways that we can, in Rainbird's case, we can bring a layer of intelligence over existing systems and integrate and become the brain that maybe to power the mental cognitive power behind RPA muscle that's going around moving data around. So, the theme is about openness. It's about APIs. It's about being integrate into various different ecosystems, and playing nicely with other technologies. And if you look at all these different worlds, I mean, Rainbird has a connector in Microsoft's marketplace. It has a connector in UiPath's marketplace. These technologies have to be interoperable so that we can get value, because no one vendor is going to give you the whole solution, right? Rainbird doesn't solve every problem that's out there. Neither does anybody else. You can pick the best of breeds and stitch those together. And I think the other thing I should just mention, sorry, on the ecosystem point is, this is all becoming democratized. This is not about, these are not just tools for IT. These are tools for the business. And I think we're now in an era where, because of the genius marketing of OpenAI with ChatGPT, everybody is awake to the fact that generative AI is here and that AI is here. And we're in a blistering hot summer now of interest in this area. So organizations, and we work very closely with our clients, we work with the big four and other organizations, where they are taking their workforce on the journey. This is not something that's being done to people. This is the whole organization is getting involved in this wave of transformation. And so that ecosystem piece is very important, because we have clients that have got whole teams of people where they provide them access to the technology, to experiment, to explore, to fail fast, and find where these technologies can add value. And that's only possible where we've gone from high code to low code to no code, and then have these ecosystems where we can plug and play into your Microsoft world or your Amazon world or whatever ecosystem you're part of.
Thank you for that, James. And I think that would be the last question for now. We are almost out of time. Thank you all for joining us today. Thank you, James, for your time. We hope you found the session insightful and valuable. We are excited to announce this is the first of our latest series of webinars. You heard James mention neuro-symbolic AI. We are going to have our next. One more question. How do you see the decision intelligence space evolving in the next 2 to 3 years? What industries benefit the most? So,
thank you, Thomas. You just won't give up. Okay, a last minute question. So I'll give a very quick answer because I know we're on time. The space where decision intelligence is the elegant. History will look back and go 10 years time. We look back and go, decision intelligence is how this all made sense. How this data world and this process world came together around decision science and the automation of decision making. It's healthcare. It's financial services, it's professional services. Every professional service company that feels threatened by generative AI can get their own back by being able to digitize their expertise and build a whole new category of services. Gartner are writing reports about this stuff. But anywhere where you really have people and a shortage of human capital, you're trying to avoid churn, you want to build this new age of digital services, this is this whole space. But I would say the top three be healthcare, financial services, and professional services. Right, so I'll be back to you because you're just about to mention about the next webinar we've got coming up.
Yes, so if there are any more questions, please do post it. We'll try and answer it to you individually after this. So please do continue asking questions. We will have a follow-up webinar and delve deeper into what James mentioned earlier about neuro-symbolic AI, and that's the technology we think that will deliver what people are really looking for, which is trust in AI. So keep an eye out for the dates. We'll be sharing that very soon. Stay tuned, and we look forward to seeing you at our next webinar. Thank you again.
Great. Thanks, everyone.